Hello everyone, welcome back. Today we will look into the Leetcode medium level problem called online stock span. Let's understand the problem statement in detail. So the problem statement mentions that we need to design an algorithm or a function that collects daily price codes for some stock as an input and returns the span of that stock's price for the current day. What is the span of the stock? The span of the stock's price in one day is the maximum number of consecutive days. Please note consecutive days. Starting from that day or the current day and going backwards, for which the stock price was less than or equal to the price of that day or current day. For example, let's say the prices of the stock in last 4 days is 7524 and the price of the stock today is 5. And when we pass this price of the stock today 5 to our algorithm, the algorithm should return span of the today is 4 as an output, because starting from today, the price of the stock was less than or equal to 5 for 4 consecutive days. You can see here, starting from today, the price of the stock was less than or equal to 5 for consecutive days, right? Now, if we have the prices like this, if we had seen some day before where the value was less than 5, but we can't consider 1 as we need to check for consecutive days only, starting from current day, going backwards, consecutive days. So we can't consider 1. Right? Answer is still 4. Let's understand with the example. Let's say on a day 1, we get stock value 100. Now, we don't have any previous days to check. So we'll just keep track of the current day, which is the value 100, for which value is 1. Considering 1 is for the current day. There are no previous days here. For day 2, let's say we get stock value 80. Now 180 day 1, day 2. For 80 also the stock span is 1, because there are no consecutive days which have price less than or equal to 80. Similarly, for day 3, the value or the span will be 1. On day 4, when we get the stock value 70, now the span here is 2. How? From the current day, which is 70, we have one more day with less value, consecutive, going backwards, 71, 2. So there are 2 days for which the stock price was less than or equal to the current day price, which is 70. When we, on day 5, when we get stock value 60, the span is 1 only, because after 60 going backwards, there is no small value than 60 or small or equal value than 60. Here it is, but we need to check consecutively. That's why the value or the span is 1. For day 6, when we receive the stock value 75, the span is 4 for the day 6. How? Starting from the current day, these are the 4 days where the stock price was less than or equal to 75. That's why the span is 4. And on day 7, when the stock value is 85, the answer is 6. Why? Because starting from today and going backwards consecutively for 6 days, the stock price was less than or equal to 85. That's why the span answer is 6. Now we understood the problem statement very clearly. Let's understand the approach to solve this problem. So this is the input which we saw in the previous slide. And this is the output, which is basically for each day, this is the stock span based on the stock price on that day. So let's understand the simple approach first. So the simple approach is, for current day, whenever we get the stock price, from that current day, we check for the previous consecutive days till we see the stock price less than or equal to the current day stock price. And this process we need to repeat for every day. So we can see that for every day we need to go back till the day we are seeing stock price less than or equal to the current day stock price. So this is not an efficient approach. This is the brute force approach. And if nth is the new day or the current day, then the worst time complexity will be O of n. How? Let's say we have the stock prices like this 10, 20, 30, 40. And when we get the stock price 50 for current day, we need to go till day 1, because till day 1 there are stock prices less than or equal to 50. And let's say we get the current price as 60, then we still need to go back to the day 1 because stock prices are less than or equal to 60. So for this, the worst time complexity is O of n. N is the number of days. So how can we optimize this? If we observe one thing, so whenever we see the current day price, for example, let's say we see 75 price for the current day, then we see that there are 3 days having stock prices less than or equal to 75. So for this, if we can store this information, let's say if we store this information 4. So for the stock price with 75, we saw 4 days where the stock price is less than or equal to 75. If we can store this information, then we don't need to store or keep track of these days, because that count we have already kept here. So we can remove them. And whenever we see the new price or the new current day price, which is 85, then we can easily use this count, which says that there are 4 days which have smaller values than 85 or the current day stock price. So we can just use this count. So for 85, 75, which is 4 days, and 80 is also less than 85. So this is 1 plus 4, 5, plus 1 for the current day, 6. So we can store this count of previous consecutive days having stock price less than or equal to the current day stock price, so that we don't need to keep track of all the days which we have visited till now. Okay? And then for 85 also, we don't need to keep track of 75 and 80 because we are already storing that count here. So we saw that for the current day where the stock price is 85, there were 5 previous days where the stock price was less than or equal to 85. But we don't need to now keep track of them because that information we are storing here as an counter. So in that way, this approach is optimized compared to our brute force approach because we don't need to keep track of days. We can easily keep track of them just as a simple counter. So here, what is the major points we are saying? We need to keep track of each day price, and for each day of the current day, the count of previous days where price is lower than or equal to the current day price. So these two things we need to keep track of. For current day, whenever we see the current day, new day, if we see the previous days with lower or equal price than the current day price, then we don't need to keep track of them because we are already putting the count of previous days. So last day with lower or equal value stock price goes out of the tracking list first. As mentioned for 85, we know that the 6 days having a stock price less than or equal to 85. So we don't need to keep track of all of this because we are already putting count here. So which data structure help us to do this? Like keep track of each day price and count of previous days. And whenever we see the day with more price, then we need to remove the previous days with lower or equal stock price. So this capability can be given by stacked words, basically last in first out and keeping track of each day so that we can backtrack to the previous days. We can easily optimize the approach using stack. Let's understand the optimized approach using stack. So let's say day 0 comes with the stock price 100. We will add entry 1, 100 to the stack. So this entry is basically count of previous days with lower or equal price than the current day price. So for a day 0 where the stock price is 100, there are no previous days. So this is basically 0 plus 1. This plus 1 is for current day. So 0 plus 1 is 1, 1 comma current day stock price, which is 100. That entry is added to the stack. So when the day 1 comes with the price 80, now there are no previous days where stock price is less than or equal to 80. So we'll add 80 to the stack like 1 comma 80. And this value we will return as a stock pan for that day. Now when the day 2 comes, similarly there are no previous days where the stock price was less than or equal to 60. So we'll just add 60, 1 comma 60 as an entry to the stack. And when the next day comes with the stock price 70, we see that previous day the stock value was 60, which is less than 70. So we'll remove from the stack, and this one we will maintain in a variable called count of previous days with lower price equal to 1. Now the previous day have a stock price 80, which is not less than 70. So now we will add current day entry to the stack. What we will add? This 1, which is for 60, 1 plus 1 for the current day. So 1 plus 1 is 2. So 2 comma 70 will be added to the stack. So for the next day, when we see the stock price 60, now the previous day have a stock value 70, so which is not less than the current day price. So we will add the current day price like this, 1 comma 60. And when we see the next day with the stock price 75, the previous day stock value is 60, which is less than 75. So we'll remove it from the stack. And this one will be added to the variable. And then 70 is also less than 75. So this will also be removed from the stack. So this 2 plus 1 become 3. 1, 2, 3. Count of previous days with lower price is this 3. Now 80 is not less than 75. So we'll now add the current day entry to the stack. What we will add? 3 plus 1 for the current day, which is 4 comma 75. Now when the next day comes with the stock price 85, so the previous day stock price 75 is less than 85, which contains the 4 as a span value, because 75, 60, 70, 60, these 4 days have a value less than or equal to 75. That's why 4. So we'll remove this from the stack because 75 is less than 85. We'll maintain that in a variable. Now 80 is also less than 85. So we'll remove this also, and 1 plus 4 is 5. Now 100 is not less than 85. So we'll add 85 entry to the stack. What we will add? This 5 plus 1 for the current day. So 5 plus 1 is 6 comma 85. So we can see that the previous approach is optimized using stack, and the time complexity here is amortized O of 1 or average O of 1. Why? Because if you see in a brute force approach, when we saw the day with stock price 75, we had to go till this day with stock price 60, because till this the stock price was less than or equal to 75. And when the day with 85 value came, we had to go till this point, till 80, right? In a previous brute force approach. But in this approach, optimized approach, when the 75 came, we removed this 60, 70, 60 because it was not needed. We were maintaining the count on a 75 itself. So for 85, the complexity to traverse this 3 days was removed, right? And that is why on an average the time complexity becomes O of 1, because for one of the day we had already removed the smaller days from the track list. So for the next day we don't have to again traverse them. So that's how the average becomes O of 1 using the optimized approach using stack. Let's understand the implementation using stack. So this is the stock spanner class where we are declaring the stack in a constructor. And this is the next method, where for every day this next method gets called with that current day price, and we return the span for that current day. So 100, 1 comma 100 will be added to the stack because stack is empty, so it will not go into the while loop. So the new entry will be added 1 comma 100, and this days 1 is for the current day. So that 1 will be returned as a output, as a stock span for day 0. Now next day comes with the stock price 80. It will not go into the while loop because 80 is not greater than 100. So it will not go into the while loop. We'll push the entry for current day, which is 1 comma 80, and return 1 as an output. So when the next day comes 60, similarly 60 is not greater than the previous day value. So we'll not go into the while loop. So it will push the entry for 60 to the stack, which is 1 comma 60. But now when the day comes with the stock price 70, stack is not empty, and 70 is greater than the previous day stock price. So we'll go into the while loop. So 1 for the current day, 1 plus 1, which is 2. So now the days becomes 2. We'll remove the entry from the stack. We'll come back to the beginning of the while loop again. Now 70 is not greater than 80. So we'll come out of the while loop, and we'll push the entry for the current day to the stack, which is 2 comma 70, and that 2 we will return as an output. And when the next day comes, which is 60, now 60 is not greater than 70, so it will not go into the while loop, and then we'll push that entry for the 60 to the stack, which is 1 comma 60. And similarly for the next day, where the stock price is 75, now 75 is greater than the previous day. It means that there are previous days with the stock value less than or equal to 75. So it will go into the while loop. 1 plus 1, which is 2, days become 2. Then again it will go into the while loop because 75 is greater than 70. So there is a previous day where stock value is less than 75, less than 75. So 2 plus 2 is 4. Now 75 is not greater than 80, so it will come out of the while loop. Now 4 comma 75 will be added to the stack, and 4 will be returned as an output. Now for the next day where the stock price is 85, stack is not empty and 85 is greater than 75. It means there is a previous day where stock price is less than 85. 75 is less than 85. So it will go into the while loop. 1 plus 4 days is 5. We'll remove that entry from the stack. Now 80 is also less than 85, right? 85 is greater than the stack top 80. So it will also be added to the days. So 5 plus 1, 6. And the stack entry will be removed. Now 100 is not less than 85. So it will not go into the while loop. It will come out of the while loop. It will push 6 comma 85 to the stack and return 6 as a output. So we can see that using stack, we implemented our optimized approach. So this is the implementation using stack with O of 1 average time complexity for this next method, which gives the stock span as an output for current day. So this is the Java implementation which we understood just now, which is implemented using a stack with O of 1 as average time complexity to give the stock span for current day based on the current day price. So let's submit this solution. So we can see it is submitted successfully. Hope you understood the explanation about the problem statement and different approaches which we discussed, like simple brute force approach, and then how we reach to the optimized stack based approach, which will definitely help you to improve your thought process. If you like the video, please share and subscribe. Thank you so much.